Okay, and for our last talk, Mohsen Soltanifar and this last presentation, and then we'll do a quick break and go to the final section. Thank you so much.
Hello, everyone. I'm Mohsen. I am a statistician in CRO pharmaceutical industry and also adjunct faculty at Northeastern University, which is headquartered in Boston and has a transplant campus in Vancouver, BC. So this talk is a kind of culmination of 2 years half work on my PhD thesis appendix defended in 2020, which I converted later to the package and published in CRAN and later in a peer-reviewed journal. So it's called SimSST, and our statistical software package to simulate a stop signal task data. So the talk is 6 sections. What is a stop signal task? It's simulating what's the R package we develop, the working example and future work and references. So what is response inhibition? Response inhibition is any situation in your daily life that you need to change, stop, or control the direction of the actions. So the types of reactive and proactive. Reactive is like you are driving, you reach to a red light, you stop your car. Proactive means that for the next intersection, you prepare stopping your car. So there are several paradigms from 1950s. They proposed to study this type of paradigms, and the 2 main ones are go, no-go task and stop signal task. A stop signal task is the advanced version of the go, no-go task. So what's that? So you sit in front of the computer, and after fixation, you see an X or O. And if it's X, you are supposed to press the X button on your gamepad. If it's O, you are supposed to press the O button. In 25% or 30% of the trials, tiny time after you see the screen, you hear the voice beep, so you shouldn't press the button. Sometimes you fail it, and that's called failed stop signal task trial. So there are several methods to study this stop signal task. Then one that we are interested in is horse race model. So the 2 races, which is the go process, the initial process, and the stop process, the secondary process is going to cut it. We are going to discuss that model. So there are 2 assumptions, stochastic assumption and contextual assumption. The stochastic assumption means these 2 processes are independent, and the contextual means that in different trials, depending to the level of that delay time, they are going to have same distribution. So the modeling distributions are mainly ExGaussian, which is the sums of normal and exponential, and also Wald. So this is the diagram that they check the distributions and study that. If the green area is bigger, means you are doing better. If it's shrinking, means you are doing not very well. So in the literature, the researchers have written several scripts in C, MATLAB, Python, and R, but they were not standalone any statistical package to simulate these types of data. So we proposed this SST package, which covers 16 scenarios, and it's dependent to 3 formal packages, GAMLAST, MASS, and DPLYR. So it is easily installed by 2 lines of code, and it has 3 main functions. The bigger function has 11 components. The last 2 components, row and D, are important. Row gives you the type of the design, and D gives you whether it's going to be the stopping of the fixed or the tracking. So here are 2 main kind of simulation scenarios, one for fixed and here one for the tracking. And there are several directions to develop this package further for other distributions like gamma, log normal, and y-ball, and also for positive probability of trigger phrases. So here we assume that when you want to stop, you stop. but sometimes even when you want to stop the process, you can't. So this scenario is not developed yet. So there is a chance to develop the package. So this is the CRAN published version and the peer-reviewed paper that we published from this package. And you can ask the organizers to get access to. And thank you all. And any questions?